All right, Mr. Diego here from Mr. Diego Tutoring and Crushing Chemistry on YouTube. Just a warning before we start the next video. I know my explanations are a little bit long, but I want you to understand what do you need to know exactly for every question. So if you're on Instagram, feel free to just push on the edge of your phone to watch it on 2x. If you're on YouTube, feel free to put it on 1.25, 1.15, 1.5x, whatever you feel most comfortable. But I will continue taking my time to explain those questions to you, because it's actually important that you know everything you need to know in order to come to the right alternative, and also be very aware of the distractors that are trying to get you, because my job is trying to defend you from those distractors, all right? All right, everybody. Today on Mr. Diego Tutoring on Instagram and Crushing Chemistry on YouTube, we're going to crush another IB style question. This question correlates pH and oxides. So we need to know what those are, right? It's a paper 1A question. Which of these period 3 oxides formed a solution with a pH lower than 7 when added to water? So let's break it down a bit, okay? Oxides, first we have to know what oxides are, right? Oxides happen when we have an element followed by oxygen only. So for example, hydroxides are NaOH, MgOH, right? Oxides are when I have an element and that element has a number, the internal coefficient. It could be the charge if it's ionic. It could be the octet rule if it's covalent. And oxygen with another number. It could be 1, right? And that what defines an oxide, okay? Now, when they say added to water, that means we're going to make an oxide solution of that something, right? We're going to make a solution of that something, and so all solutions have pHs. Now, it wants to know which of these oxides, when added to water, so when we have an oxide solution, will have a pH lower than 7, okay? So just to remind you, the pH scale goes from 0 to 14, anywhere between 0 and 6.99999 up until 7. It's acidic. Everything after 7, it's considered alkaline or basic. And exactly 7.0, it's considered neutral. So the rule of thumb is there's 2 types of oxides. There are 2 types of elements that can be bonded with oxygen, okay? Metal and non-metal. So when you have a metal oxide, so that let's say sodium, magnesium, aluminum, right? Sodium is a group 1 metal, magnesium is a group 2 metal. You got to be careful with group 13 or group 3, right? Because you have metals, metalloids, and non-metals in that group. But in case of aluminum, aluminum is a metal, right? We make cans out of it. When you have metal oxides, rule of thumb, your oxide solutions are going to be alkaline or basic. They're going to have a pH higher than 7, right? Which is what defines an alkaline or basic solution. When you have non-metal oxides, for example, CO2, the one that we breathe out, right? NO2, like nitrogen oxides, sulfur oxides, non-metal oxides, you're going to have acidic solutions, okay? So that's the rule of thumb. Metal oxides, alkaline solutions, pH higher than 7. Non-metal oxides, acidic solution, pH lower than 7. The question wants to know which of the alternatives is going to have a pH lower than 7. This little sign here means lower, right? So we got aluminum oxide. So aluminum is a metal, and metal oxide solutions are alkaline, so definitely not. Magnesium oxide, magnesium is a group 2 metal, so definitely not. Sodium oxide, sodium is a group 1 metal, so definitely not. Tetraphosphorus hexa oxide, okay, just the 4 and the 6. Tetraphosphorus hexa oxide or phosphorus oxide. Phosphorus is a non-metal and therefore is going to have an acidic solution, is going to make an acidic solution when added to water. So the answer is the only oxide out of these alternatives here that are going to yield an acidic pH, a pH lower than 7 when added to water, is the oxide that has phosphorus bonded to oxygen. If you want to book a private tutoring session with me, just hit me on the DMs, send me an email, follow my social media accounts, and I'll see you on the next one when we crush some more IB style questions. Have a good one, y'all. See you later.